Hello, welcome back. Today we're going to be looking at the chain rule. But today we're going to be looking at it when we apply it with the product and the quotient rule. So before we go ahead and review. So let's say we have a function w of x, and it's defined as the cosine cubed of 3x squared. We saw this yesterday and in our homework. We don't like the 3 where it's at. So what we said yesterday was we always want to rewrite it, the cosine of 3x squared cubed. And now we can take the derivative. When we take the derivative, we have our chain rule here because we have inside the parentheses here. And in this case, our outside is this cubic function. And that can give us this 3 times the cosine. Remember, we're not messing with the inside just yet. We're going to leave that alone. 3x squared. And of course, when we subtract our power, that becomes a 2. Now we're going to do the inside. So there's our outside, and now we have to do the inside. The derivative of cosine, that's going to be negative sine. And again, this is going to stay 3x squared. And be careful, this is our double chain rule. We have another inside this 3x squared. So I have to do, there we go, this chain rule again. And that's going to be times the derivative of 3x squared, which is 6x. And so we have 2 insides here. Remember, and we're just going to always multiply them together. We talked about that Russian nesting doll yesterday. And that's kind of the same idea. So the chain rule from yesterday, we talked about this is how we take the derivative of a composite function. We're going to take the derivative of the outside and multiply that by the derivative of the inside. And that's what we saw up here. Remember, chain rule will occur when there's a function inside of another function. The secret is to look for parentheses. So today we're going to take a look at how we take the derivative using a combination of the derivative rules. We will want to look at what we call the big picture. So let's take a look at an example. Here we have w of x. Now notice we have 2 functions multiplied by each other. And remember, in this case, this x cubed is not a constant. So when we take the derivative, we are multiplying. Now, over here on this x to the 4th minus 6x to the 5th, this is a chain rule. However, when we think of the big picture, notice we're taking this chain rule and we are multiplying. So the big picture here is the product rule. So what we're going to do when we take the derivative, we are going to use the product rule. And we'll talk about how the chain rule comes into play with that in just a few moments. So let's go ahead and try this real fast. When we want to take the derivative using the product rule, don't forget the product rule, the first times the derivative of the second, plus the second times the derivative of the first. So let's see here. The first is just x cubed, so I'm just going to leave that alone. My second times... Now, when we take the derivative of our second function, this is where we're going to apply the chain rule right here. Because I'm taking the derivative of an inside function here. So the derivative of our second, just like we did yesterday, we're going to bring down the 5. So this is going to become times 5 times, remember from yesterday, leave the inside function alone, raise that to the 4th, multiply that by the derivative of the inside. So our inside derivative, use parentheses, 4x cubed minus 6. Oh, that's ugly. Plus, now we're going to take the second function, which is just this x to the 4th minus 6x to the 5th, and now we're going to multiply that by the derivative of the first, which is easy. That's just 3x squared. And this is our derivative. Now, is it nice looking? No. So we're going to leave it alone. Let's just leave that right there. These aren't going to look very nice, but we're not going to clean it up. Now, you can clean this up quite a bit, but don't do that. Just leave it alone. All right, so let's take a look at number 2. Now, for number 2, the same thing. We are multiplying here. So my big picture, again, is product. But notice here I have the square root right here. That's my chain rule. I'm going to rewrite this times 1 minus x cubed to the 1/2. I'm going to write it like this, so it makes it look a little bit nicer for us. But now when we take the derivative f prime of x, we're going to get, let's see, the first times the derivative of the second. Remember, the second is my chain rule. So the first is x squared times the derivative of the second, use your power rule, 1/2 1 minus x cubed to the negative 1/2. We'll deal with that later. Don't forget, we do have a chain. What's the derivative of my inside? And that's just this negative 3x squared. Plus, now we're going to do the rest of it, the second, which is just this 1 minus x cubed to the 1/2 times the derivative of the first, which is 2x. And there's our derivative. But there is one thing you might remember we don't like. We don't like this negative exponent there. So we have to rewrite that. So let's go ahead and do that. What we'll wind up with here, we'll wind up with a fraction bar. The x squared here and this negative 3x squared can be multiplied together to give us negative 3x to the 4th. On the bottom, we're going to have the 2 and this 1 minus x cubed to the 1/2. Plus, this has no negative exponent, so I'm just going to leave that alone. Don't touch it. Just leave it alone. And there's your derivative. And if you look in the back of the books, those will be nice and simplified. Don't even worry about that. All right. Wow, that is ugly. These aren't going to turn out nice. So you're not going to have as many to do tonight for practice. But remember, you do want to practice these. I know these are tough, but you do want to practice these because you want to get really good at it, because this is not a skill that's going to go away anytime soon. So for number 3, notice again on the bottom of our fraction here, we do have a chain rule. But what's the big picture? That chain is just part of my fraction. I'm dividing. So we're going to use our quotient rule here. So let's go and review that. Remember, that is low d high minus high d low all over low squared. So chain rule, quotient rule is ugly, but it works for us pretty nicely. So when we take the derivative, my rule says take the bottom function, the low, 2x minus 1 squared times the derivative of the top. Use parentheses, minus high, which is this 3x plus 2 times the derivative of the bottom. Now when we take the derivative of the bottom, this is where my chain rule is. We're going to get 2 times 2x minus 1 to the first, and don't forget the inside. What's the derivative of this 2x minus 1? That's just going to become times 2. All over the bottom, 2x minus 1 squared. It's already squared, so that's just going to be to the 4th now. Let me make that look like a better minus 1 here. Minus 1. There we go. We're done. That's it. You can simplify. For example, if I wanted to, I could divide everything by a 2x minus 1. I can simplify, but man, just get the answer for now. We'll worry about the algebra later. I just want to see if you guys get an answer. All right, so let's take a look at number 4. 4 is the same exact type of question. It looks ugly. Matter of fact, so our big picture, this is going to be our quotient rule. It's going to be ugly, but that's okay. The derivatives themselves really aren't that hard. On top, though, notice I am going to have a chain. We can recognize chain because I have something inside of parentheses, which is the same thing for the bottom. So, but the big picture is quotient rule, which means we have to use our quotient rule, not the chain rule, until we see it. F prime of x, notice it's going to be fun when the teacher does a really long fraction bar, low cosine 3x d high. When I take the derivative of the top, this is my chain rule. 3 x to the 4th plus 4x squared, chain rule, times the derivative of the inside, 4x cubed plus 4 minus high x to the 4th plus 4x cubed. Ooh, D low. Oh, this is nasty. The derivative cosine, negative sine 3x. Chain rule again, times 3. All of this over the cosine of 3x squared. Leave it alone. Don't touch it. Don't be like, I'm going to be a hero and I'm going to try to simplify that. It's just a derivative. We can take it. Now, if you really like to hate yourself, take the second derivative. And that's when they never found his body again. All right, number 5. For number 5 is like, hey, where's my space? Well, to do that, we're going to go down here. Now, this one, big picture. Notice on the inside, we do have a quotient rule. But notice on the outside, we have a chain rule. And that chain rule, because it's outside of everything, that's our big picture. This one is a chain. Whoop, can't spell picture today. This one is a chain rule. So let's go and take the derivative. I got to come down here for it. H prime of x equals, the chain rule says take the derivative of the outside, 3 times 3x minus 1 over x squared plus 3. And now we're going to do the derivative of the inside. Well, the inside, so remember this, whoops, sorry, I forgot my square there. Need my square, it was a 3, need my square. There's the derivative of the outside. And now, let's go ahead and find the derivative of our inside, which we know is our quotient rule. So, because the inside I'm dividing, my inside here is division, so my rule says to use quotient, which is low, use parentheses, d high, well, what's the derivative of the top, is 3, minus high, 3x minus 1, times what's the derivative of our bottom here, that's just going to be 2x, all over the bottom squared, x squared plus 3 squared. And there's your inside derivative. We're done. Don't go any further than that. Please leave that alone. All right, go to the next video and we'll take a look. We'll continue on with some more examples. I'll see you then. Bye.